Hello, everybody. How are you doing? Hopefully you're doing amazing. This is part 2 of our Chapter 2 Chemistry PowerPoint, and we're going to review water. I know what you're thinking. Mr. Bushman, we already had a whole PowerPoint on water. Well, it turns out you're right, but water's really important, and so we want to make sure that we go over it again. I want to remind you that all of water's properties are due to its polar nature. And it's polar because it has a really big oxygen atom and 2 very small hydrogen atoms. And so the hydrogen atoms can't attract the electron nearly as much as the oxygen can as they share it. Consequently, the oxygen becomes partially negative and the hydrogen becomes partially positive. This enables it to interact with negative and positive forces, oftentimes by doing hydrogen bonding. Hydrogen Okay, hydrogen bonding is when a partially negative molecule is attracted to a partially positive molecule, using water again as our example. We've got our partial negatives and our partial positives. This attraction is called a hydrogen bond. It is weaker than ionic or covalent bonds. Because of hydrogen bonding and water's polar nature, water can do cohesion, where like substances are attracted. These 2 water molecules would be an example of cohesion. But it can also do adhesion. Where unlike substances are attracted. And again, both are due to water's polar nature. Water, and in fact most molecules, have 3 states of matter. And they can be solid, liquid, or gas. Is that true for everything? No, there's another weird state in stars called plasma, but we're biologists, and these are the 3 states we see 99.999% of the time. I'm sure if you took chemistry, you're familiar with this graph here, where we have time, and we have temperature, and the temperature is rising as time goes by, and then it levels off. And then it's rising, and then it levels off, and then it's rising again. And these are changes in states of matter. So change in states of matter. In this case, we are going from liquid to gas. That's the heat of vaporization. For water, that's typically 100 degrees Celsius. And here we are going from solid to liquid, and that is the melting point. And this is why, if given the choice, it's a weird choice, but if given the choice, you'd rather be burnt by 100 degrees liquid water than 100 degrees gas, because gas has all this extra energy, so it can do more damage. Just fun food for thought. Let's talk about pH. So pH is a measure of a substance's willingness to donate hydrogen ions. And we know that acids donate H+, strong acids donate them very readily, and that bases receive. And yes, I know that if you're in a chemistry class, that doesn't really exist. Remember water's polar nature? Well, that oxygen bonds with that little hydrogen ion, and you get H3O+. But for our class, H+ is fine to remember. Continuing with pH, the pH scale goes from 1 to 14. This is acid, very, very strong acid. This is a very strong base. The scale saved it kind of. Let's just cross it out. Is logarithmic, meaning that pH 6 is 10 times more acidic than pH 7. Yes? Yes. Take a break here and watch the Mr. Anderson video in the description. Remember, Mr. Anderson is amazing. Bozeman Science is awesome, and we're very lucky to have it as a resource. It's just good to hear this stuff from multiple points of view, not just from me. You should be back from the video now, so let's continue on to the topic that's going to take up a lot of the summer assignment. We're just going to scratch the surface in this video, but a lot of the summer assignment is about macromolecules. And these are large organic molecules that are made of repeating units. Those So those repeating units are given the generic name monomer. And then a chain of monomers is called a polymer. That's where a little confusion comes in, and frankly, that's why you're taking our summer course. And so I could talk about, for example, rubisco. Rubisco. Okay, rubisco is a protein and therefore a type of monitor. However, the category protein is one of the 4 types of macromolecules. So you can kind of look at it like this. Car is macromolecule. Honda is a type of macromolecule because it's a type of car. Honda Civic is a specific kind of car or a specific kind of macromolecule, which we would call a polymer. Hopefully that helps. I just thought of that right now. I'd never said that analogy before, and that's why you guys are awesome, and this is a lot of fun for me. Guys, I want to remind you, thank you for taking the time to sacrifice for your grandparents and really doing the good work to get this disease under control. I appreciate you guys doing your social distancing and wearing your mask so that things can return to normal. You guys are awesome. Till next time, talk to you later.